We go with another lecture on the evidence of the evolution, that's the paleontological evidences in favor of evolution. In the earlier lectures, we tried to understand the morphoanatomical evidences in favor of evolution. Then we studied the embryological evidences in favor of evolution, and now we are going to study the paleontological evidences in favor of evolution. Before we begin a detailed discussion on the paleontological evidences in favor of evolution, it's important to understand what is paleontology. Basically, paleontology is the branch of biology which deals with the study of the fossils. So, the paleontological evidences are those evidences which are supplied from the field of paleontology, or it means these are the fossil evidences in favor of evolution. Uh, so first of all, let me discuss one very important thing which is asked in your NEET examination. This question has been repeated many a times in your NEET examination. When you discuss the different types of evidences in favor of evolution, there is a special category of evidences which you call as the paleontological evidences, which are called as the direct evidences in favor of evolution. No other evidence, either morphoanatomical or embryological or cytological or biochemical or physical evidence in favor of evolution cannot be said to be the direct evidence in favor of evolution. It's only the paleontological evidences which are given the credit of having the direct evidence of evolution, because in paleontological evidence we directly study the fossils and they directly give us an insight into the life which was present on this planet in the remote past. So let's discuss something about the definition regarding the fossils. Basically, the term fossil has been derived from a Latin word which we call as fossilum. It is the word which we call as fossilum. The fossilum means to dig out, to dig out something, to dig out something. Basically, most of the fossils which are present or which we excavate, we get them from the they are breed in the what we call as the interior of the earth, and we get them from there by digging them out. But it's not always the case that each fossil you see that will be digged out from the surface or the interior of the earth. There are many fossils which you find in the ice and you find in the resins, etc. But this is a general notion. We use the term of fossil for these ancient remains of the organisms which lived on this planet in the ancient past. So let's discuss how these fossils give us an insight into the evolution, or how they support the concept of the evolution. Before we go detailed about this thing, let's discuss first of all about some types of the fossils. The first important fossil you are going to understand over here is the unaltered fossil. The word alteration means some change, but over here we have used the word unaltered. It means where there is no change, unaltered fossil. So these are those fossils which have not underwent any change. So what does that mean, that they have not underwent any change? You see, if a fossil gets buried in the ice, in the polar ice caps like that in the Siberia, or if it gets buried in the resinous material, where there is no possibility of the decomposition, if there is no possibility of the decomposition, then what will happen? All and each and every what we call as the detail of that very fossil will be preserved. For example, we take over here the example of woolly mammoth. This is an animal which used to live on this planet in the ancient past, and we have got the this fossil of this very animal from the polar ice caps of the Siberia, and you see that there is no chance of decomposition in the ice which has accumulated there from from millions of years, which has accumulated there. So we say that those fossils which we get from the polar ice caps, from the freezed what we call as the ice, or from the resinous material, we call them as unaltered fossils. One such example I have already quoted is that of the woolly mammoth. You see, the woolly mammoth was it was obtained, it was excavated out from the polar ice caps. Sorry, it was excavated out in the from the Siberia, from the ice, and you see that each and every detail of this fossil was preserved because it had not underwent any decomposition. So it's an example of the this unaltered fossil. Many scientists say that the woolly mammoth, the flesh of this very animal, was so fresh when it was excavated out from the ice that its flesh was eaten by the dog. So was it fresh. So in these fossils, the thing which is of importance is that each and every detail of there is preserved. We can understand each and every think about them, we can understand their digestive tracts, we can understand the size of their brains, we can understand their morphology, anatomy, biochemistry, we can understand each and everything about them because they have not underwent any alteration or any change. So they are something very special about the fossils. Then there is another category of fossils which we call as petrifications. Let's move towards the petrifications. Now, petrifications, by this diagram, you can understand the petrifications. Inside the body of an organism, there is organic matter. There's organic matter. When the organism dies, gets buried in the rocks or in the earth somewhere, you see the organic matter of this very organism gets replaced in the course of time. It gets replaced, and the mineral matter percolates inside the body of an organism, and it takes the place of the cavities inside and many other things which are present inside the body of an animal. They get decomposed. When they get decomposed, you see each and everything whichever is present inside that perishes away. The organic matter is nowhere then there, but the place that was occupied earlier by the organic matter, that's now occupied by the mineral matter. And these type of the fossils in which the organic matter has been solely or wholly replaced by the mineral matter, they are known as the petrifications. So this is all about the petrifications. So in petrifications, you have to remember that the organic matter in the animals or in any organism of whose fossil we are going to discuss over here, the organic matter in them is replaced by the mineral matter. Now, the third one is the compressions. Now, what happens in the compressions? These are compressed carbonaceous remains which get deposited over the fossils. If we give this example, let's try to understand compressions by this diagram. Now, this diagram was earlier used for understanding the petrification. Now, let's make this diagram and let's understand the compressions by using this diagram. Now, what happens in compressions? The outer details of the fossil are preserved. However, the internal details disappear. It means to say that a compressed carbonaceous layer of matter gets deposited over the body of the organism, and as a result, the external details get preserved and the internal details disappear. So there are now many other types of the fossils which we are going to discuss, but we shall be discussing those fossils in a separate lecture. Hope that you have understood this lecture very well.